Hello guys, so in this video I will discuss something called the Integrated Information Theory or IIT. It's a theory of consciousness proposed by Tononi, Professor Tononi, and what Integrated Information Theory says is that basically there are two terms, integrated and information. So basically, roughly speaking, without going into the mathematical aspects of the theory claims that for a complex system, by a complex system I mean preferably a system with a huge number of simple parts and not a small number of large parts. Okay, so for such a system, such an interacting system, a system that can change its state with time, a lot of interacting parts, for such a system to have consciousness, to be conscious, it must satisfy two conditions. Number one, it must be an integrated whole, and that is why the theory is called integrated information theory. Now what do I mean by integrated whole? It basically means is that it must be the total system must be all the parts of the system, they must be in close correspondence with all the other parts. I mean, it's not necessary that they should be at a very close distance to the other parts, but there should be a interconnectedness, a good connectivity throughout the system, and no parts of the system should be completely independent of the other parts. Because if suppose two parts are independent, then they are basically essentially two independent conscious systems. Then one part cannot affect the other part and cannot be a part of the subjective experience of the other part. Then we cannot treat the system as a single consciousness, single conscious system. So this is what we mean by integrated whole, the number one condition. The second condition is that the system must be capable of storing, processing, storing, and recalling information. It must be capable of processing information, and that is why integrated information theory, because the processing of information, that is what differentiates consciousness from the non-living objects, because they cannot process information. They can, we can store data in them in some rudimentary sense, but we can process the information and we can extract the useful information from a set of raw data, and then we can store the information, and if required we can recall the information. That is the defining feature of consciousness. And of course, there's a lot of mathematics also. It's a very good theory actually. It's not just this, but this is a basic idea. Now, Max Tegmark, the MIT physicist, he building on this Tononi's integrated information theory. He proposed that uh, consciousness is could be a new state of matter. He says that consciousness is the way information feels when it is being processed. So far we have this idea that consciousness is kind of, roughly speaking, it's the way we feel. But according to Tegmark, no, that's not the case. Suppose due to the complex interaction and the required arrangement of all the neurons in the brain, suppose we information emerges from this, the arrangement and interaction of the neurons. Now at this level, it's information that has emerged. Consciousness has not yet emerged. Now, so information has emerged. So information emerges from the way from our brain, but now consciousness emerges from the way information feels when it is being processed. So it is kind of doubly substrate independent. To use Tegmark's own terms, it's doubly independent of the substrate. By substrate I mean the physical matter of the brain. So consciousness is not independent of the brain, of course, but it is independent of the physical matter of the brain. It's not dependent. Basically, if we can recreate the same patterns, the same everything, then theoretically it should be possible to simulate consciousness in any complex system with a sufficiently large number of parts interacting in the correct way. It's not necessarily it's not confined. I mean, it's not that it has to be the neurons of the human brain or whatever. But the important point to realize here is that according to Tegmark, he says that it's doubly independent of the substrate. So information is independent of the physical matter of the brain, and consciousness is doubly independent of the physical matter, because consciousness is the way information feels when it is being processed, according to Tegmark. It's just a theory, just a hypothesis. Now, so one thing is that, you see, when I say it's independent of the consciousness is independent of the physical matter of the brain, but it is dependent on the physical structure of the brain, the arrangement of the neurons and the interaction of the neurons. It's not independent of that, although it's independent of the substrate. Now the last point I want to discuss in this video is that when we say it's like uh, for consciousness to emerge, or for any well organized behavior to emerge, say self organization and all these terms we study in complexity science, Both the arrangement of the parts as well as the interaction between the parts, both of it's important. There's a simple analogy to illustrate that why this must be the case without even going into the intricacies or the technicalities of the subject. Suppose you see a collection of dots, and say the dots remind you of an elephant. Suppose the dots are arranged in a particular manner, and by looking at the dots, you are reminded of an elephant. Now, the dots, fundamentally, it's just a collection of dots. Just it's not an actual elephant or not even a picture of an elephant. It's just a collection of dots, and it's not changing. The dots are not moving. Nothing is changing. So the dots are arranged in a particular pattern, and that arrangement reminds you of an elephant. But but it's not only the arrangement that matters. By looking at that particular pattern, that particular collection of dots, whatever you call it, there is some interaction happening in your brain. Your subjective experience is changing. First of all, you look at it, and your first impression is it's a collection of dots. Then you say that, oh, it resembles an elephant. So your subjective experience is changing with time, very quickly, but it's changing with time. To account for this change, some some interaction must be going on in your brain. The different parts of your brain, neurons, synaptic connections, whatever, they must be, you know, there must be some changes going on, some transformations going on, and this is why the interaction part is important. And It's important to keep in mind, to realize that this interaction should be such that they will not destroy the arrangement, the overall arrangement. Of course, that if there's a lot of interaction going on, the arrangement will change, but it must be within a particular range, so that the total system, I mean, the arrangement must be in the allowed range, because if it moves beyond that range, then consciousness will no longer operate, consciousness will no longer be present. That is also an important part. So, but you may ask that why are humans, I mean, how could consciousness emerge? Because it might sound like a very fragile system. Like if the interaction goes out of the range, the arrangement goes out of the range, then consciousness should suddenly flicker out. So, but over millions of years, we conscious creatures have evolved from the days of those prehistoric creatures to dinosaurs and to us humans. So, but actually consciousness is not fragile, because once consciousness has emerged, how it initially emerged, maybe that is accidental, but once it has emerged, uh, you know it's kind of, if you study self-organization and all, complex systems, many complex systems have this property. They can organize themselves. That is why it's called self-organization. They can organize themselves without any external factor or external control into a very complex and a very self-sustaining system, which can sustain its state for, like for us, if you consider humans, we can sustain ourselves for almost 80 years or 85 years. That's the average lifespan. I mean, around 75, 80 years, whatever, except in cases of accidents or untimely deaths. So because it's not actually fragile, it's not just that, because these interactions are happening, nobody's controlling it, it's all a spontaneous process, but it has evolved in such a manner that all these interactions will automatically happen in such a way that it will not go out of this range, because this is the most likely configuration. Just giving the rough idea. All of this, they have a very logical and mathematical background, mathematical framework, but I'll not be discussing all of that in this video. But yeah, that is the important point, that both the arrangement and the interaction are important. Like people talking about digital immortality. So if we can maybe say map all the neurons of our brain and maybe map it in a computer, say we can create a 3D map of the human brain, which technically neuroscientists call it the connectome. So that only takes care of the arrangement part. Even if we succeed in doing that, although that's a very complicated task, almost impossible task as of now, but then we only take care of the arrangement. Then we have to pass maybe electrical signals or something to simulate the neurotransmitters that are darting between the synapses of my brain, and we have to do it in the precise right range, in precisely the right way. Only then, even then, the question arises that even after doing all of this, will that digital artificial digital consciousness which we have created, will that system be us? Will it be me? Will it be actually conscious? Will it be able to feel the world, feel all of the emotions that a human being, that an actual conscious creature can? I mean, is it that easy to recreate nature? That is the main question. Thing is that even if we can somehow recreate a digital version of consciousness, but that is not really immortality, because we also need to make sure that this system which we've created, it must be capable of changing itself in response to external conditions, and it should be able to change its internal structure with time, because otherwise, if it doesn't, then it cannot form new memories, it cannot It cannot forget old memories, it cannot form new memories, it cannot even perceive the passage of time. Suppose you are fixed in time, you cannot perceive anything. You are just fixed in the point of time. You will not die, so in technically you are immortal, but you don't have the sense that time is passing, something is changing. You cannot form new memories, you cannot have new experiences. So under those circumstances, then there is no point to immortality. I mean, compared to that, I think our 80 years life is mortal life is better. But even that may be possible in the far future. Maybe we could even make a system which is able to change have new experiences and change its structure by itself in response to external stimuli. Yeah, but the main point of this video is that I want to impress upon you this fact, that emphasize on this fact, that for consciousness to emerge or for any kind of organized behavior to emerge from a complex system, both the arrangement between all of the parts of the system as well as the interaction between the parts, we need to take into account both of this, and both of this must happen in some particular range, and one should not destroy the other, and it's all happening in a particular balance, in a perfect harmony with each other. And that is the beauty of all this stuff. Like, if you look at say a particular part of the system, you may think that it's a very complex system, it's totally chaotic and all, it's kind of random, like it's unpredictable and random. And yeah, to some extent it actually is unpredictable. But if you look at the entire system, you see that there's a beautiful order, this order arising out of the randomness. So that is why I say, and it's you see, if you that is my kind of, just like that's kind of my, you can say, my tagline in my website. Everywhere it's written, ordered complexity is the fortunate product of random processes. So deep down, these processes are kind of random, and they are definitely spontaneous. Nobody is controlling them, and they've evolved according to the laws of physics, if we go fundamentally. And yeah, from the laws of physics, the laws of chemistry, the laws of biochemistry, the laws of biology, even probably the laws of psychology, all of these have emerged. But yeah, but these processes are random in the sense that we cannot totally predict it. We can only predict the possibilities and the probabilities. But that is at the fundamental level, at the level of the individual parts or particles, whatever. But when I look at the entire system, we see that there is the complex system, we see that there is some order in the system. And that is why ordered complexity is nothing but a product of complete randomness, of random processes. And why I say that ordered complexity is a fortunate product of random processes, well, the use of the term fortunate is pretty ironic, because sometimes I feel like maybe if consciousness did not emerge, then maybe maybe there would be no life on earth. Would that be better? Because currently the present situation of everything, I don't know if it's just my personal life, or it holds for in general most of people. But yeah, I don't know if whether it's fortunate or unfortunate that we are conscious. But the point is that if we were not conscious, we will not even be able to ask this question, that whether it's fortunate or unfortunate. So in some sense it is probably fortunate, and that's why I decided uh, to use the term fortunate in the quote. Ordered complexity is a fortunate product of random processes. And yeah, why I use the word random? Because all of this, you see, mutations in genetics and all, even in physics, at the quantum limits, there is a certain degree of randomness. Yeah, whether in the future we'll find out that whether there is some underlying order even beyond this randomness, even underlying, even deep down this randomness, that depends. But as of now, according to science, there is some randomness in nature at the fundamental level. But yeah, from that randomness, a beautiful order emerges at our level, at the macroscopic level. Yeah, we can predict a lot of things at our level, and there is a beautiful order here. But if we go deep down at the level of electrons and all of the stuff, we see that there is it's kind of random. So that's all I wanted to say in this video, guys. And just in case you're wondering where I am, you see, it's actually like I probably I mentioned in one of my previous videos that I visited North Bengal for the last couple of days, and it's actually called a Boxa forest, and it's a very pretty dense forest, and it's a kind of homestay in the middle of the forest. I don't know if you can see the nearby these trees and all, but it's actually a deep forest. In the morning you can see the good view, and I'm just sitting in the, it's actually pretty cold in the night here, and I'm just sitting in the balcony, kind of making this video on consciousness. And I'm just wondering, sitting in the lap of nature, I'm wondering, there are a lot of other conscious creatures roaming around. I cannot see them maybe, but elephants, bisons, maybe even leopards, I don't know, not nearby, but yeah, definitely in this jungle. It's a very huge area. So yeah, it feels pretty great. And I hope and this was a very important video actually, because I've talked with a lot of people about consciousness, and they miss this point. I mean, they miss the concept actually, why it's always said that it's arrangement plus interaction, and what is IIT, I mean integrated information theory. So I think that's why I made the video, and it's yeah, so I think that's all for this video. I will not further make it any longer. It's already 15 minutes, and I hope it was helpful. So guys, yeah, thank you very much.